welcome everyone.
I can find it on, like, there's no...
There is a... Welcome everyone. So this is Math 51. Calculus. I'm your professor for the semester. I've been a professor at Cal since 2004, so I guess longer than many of you have been around. I've been teaching this class many times. I've seen many generations of students like you, and I always look forward to teaching you. And I look forward to teaching this particular class. Now, why? So, because calculus is an entry point for you into the world of math and sciences and engineering. So calculus, the reason to take this class is one. So I literally mean it's a language, okay? If you don't speak this language and speak it fluently, like it's your second nature, the doors to these disciplines will be closed for you, okay? In the age of AI, computers can do lots of stuff for us, but they can't teach you French. You want to take AI and go. It might help you on your French exam here. What you'll be doing is you're going to be, I don't know why I picked France, whatever. You're going to be having a career in France. You want to live there. You want to operate there. For that, you got to be fluent. No computer on earth is going to help you. Okay? That's the main reason. The second main reason is a university is a wonderful place. But there are very, very few classes that will teach you more than just the content of the class. And actually, in one very, very practical way, when you come out of this class, I guarantee you 100% that you're going to come out smarter. You will come out with a better, faster brain. Okay? And this is really true. Calculus is a little like, it's like going to the gym. What going to the gym does for your muscles, this stuff does for your brain, okay? Your brain, your neurons will be firing faster, which is kind of pretty amazing. But of course, this is only true if you put in the work. All right. So, let's get down to business, okay? Textbook. Now, actually, usually the textbook stuff is kind of the boring thing, right? I'll just like swim right through it. It turns out this semester it's a little bit interesting. So our textbook is going to be Stewart 8th edition. Now, we had a little interesting thing with this happen, which is that a week ago, the publisher came. These guys who publish books and takes hundreds of dollars from you, they came a week ago and said, guess what? We changed the textbook. That's it. Then the bookstore comes to me and says, do you want a new textbook? I'm like, sure, why not? What's the difference? He says, I don't know. Let me go check with the publisher. The publisher said they changed 20% of the book, and they did not tell us. okay? Which is just incomprehensible. So we are staying with the old edition of the book, 8th edition, okay? You might even be able to get away with even older editions. And the main thing that's going to be different, calculus is the same for the last 200 years, nothing has changed. The main thing that's going to be different is the problem numbers in the book. So I'll be assigning homework from the book. The problem numbers may not align, and in particular, that's the thing that they messed up. So A, you can save money, get any old edition of the book. You will need it. However, you will need it for the content, right? To make sure that there's absolutely no confusion about the problem numbers, what I'm going to do is we will also post the page from the relevant edition of the book with the actual problem. So you will be sure which problems you're solving. There's no worry about that, okay? And then everything's fine. Sounds good? Cool. And if you bought that 9th edition and it's more expensive than some other one, please do send it back, because we told them, no, we are not doing this. I mean, the publisher. All right. Any questions about this? Yep.
Well, I tried to buy the 9th edition of the book, but it haven't come. So I don't have the textbook right now.
You can get any old edition. And there are many, many floating around. The library is full of them, right? Nice place to study, go into the library. It's nice and quiet. They'll have 1 million books, okay? All right. So our main webpage is on B courses. And you should all have access to it, where all the nitty-gritty details that I'm going to tell you about the class now are spelled out. All right, so let's see. Grading policy. Actually, before I get to grading policy, one more thing. We will not be doing course capture, okay? Not as a default. If you have to be out of town and you have to miss a lecture, you can write to the head GSI and ask him for permission to view one particular lecture, but as a default, I will not be recording this class. There have been studies done which tested the correlation between students viewing the class on course capture and their actual final grade, their performance in the class, and there's a total anti-correlation. In other words, you view this on course capture, you will learn less, okay? This class is really designed for one purpose only, which is for you to learn the calculus. So these doors are open for you, okay? I'm not going to close those doors for you on day one, okay? I know it's tempting to sleep in, to do whatever. So I don't want to close those doors for you on day one. No course capture. All right, so back to grading policy. We'll have one midterm, 25%. And that midterm will be March 6th in class. 25% of your grade. We'll have final exam, 45%. That is going to be May 12th. I don't know where. We'll have quizzes, 5 quizzes. The dates are on the website. The very first quiz is going to be February. Quizzes are done in section. Quiz 1 is February 5th. Okay? You should expect here they're about 20 minutes. Let's say equal 20 minutes, just so. Okay? And finally, you'll see that this doesn't add up. There's 5% homework. All right. Now, so homework you see is the least amount of your grade, just 5%, okay? However, homework is the most essential part of this class, okay? You do well on your homework, meaning diligently, the rest of the class is going to be completely straightforward, because my intent is to make it straightforward, to make it so that anybody who's done their homework and done it well can just sail through the quizzes, the midterm, and the final, okay? And the quizzes, the midterm, and the final are there to just help you check, have you really done your homework thoroughly, okay? To help you assess your own performance on the homework, okay? So, homework, how are we going to do it? So, I assign an absolute mountain of homework. Well, okay, I don't want to assign so much homework that you can't do it. My intent is that you can do the homework, okay? So I will look for the feedback from you, okay? So I've been teaching this for 20 years, so I have some experience about how much you can do. But even so, right, if I'm doing too much, you can raise your hand, say, we really can't keep up with this. It's too much. It's okay. I'll adjust. The point is that you aim to do all of it, okay? And you will, I'm going to spend a lot of time talking about homework because it is the most essential part of this class. So how will we do it? Okay, so how to do homework. Okay, you laugh at me like, what do you mean, how to do homework? I know how to do homework. Well, I want you to do it. There is an algorithm, okay, for learning math. An algorithm means it's like, foolproof steps. You follow the steps, everything goes well. You don't follow the steps, you're on your own, okay? But if you do follow the steps, it works, okay? So here's how you do it. So step 1. You read the book, go to lecture, and try to understand what's said, okay? Step 2, do simpler problems, namely first problems. From homework. Here, you are testing whether you've understood the book and the material from class, okay? Now, if you are unable to do a problem, that's fine. But by unable, I mean you're uncertain if you did it correctly. That's fine. That's part of the learning process, right? Nobody gets everything like, I get it immediately, right? You will not have understood some things. And these early problems are testing your understanding, are there to help you gauge what you have not understood. If you have problem doing a problem, it means you haven't quite understood something. So then you go back to the book, you go back to class notes, and you revisit that part, okay? It could be that you didn't understand the material being taught in class. There could be another issue, okay, which is often what actually trips people up, okay? Calculus is conceptually a beautiful and simple and easy thing. However, it requires that you have command of algebra, the stuff you learn in middle school, okay, or high school. It's possible that you have holes in your algebra. And if you do not fill those holes, you will not be able to do well. This is your chance to fill those holes. So, along with seeing whether you understood what's being said in the book, you have to make sure that every step that I do, that the book does, is crystal clear, right? That you know math is unbelievably egalitarian. An equal sign in math means equal. The left side and the right side of the equal sign are really, truly equal, okay? And when a book says that something is equal to something else, you have to know why that's true. There is no magic, okay? If you're unsure why they say that something is equal to something else, say in algebraic operations, you gotta go back and revisit those operations, okay? So, so you check understanding of material and algebra. Like operations with fractions, right? Operations with brackets and so on. Great. And finally, step 3. So here, you're using this to eliminate gaps. Step 3, do more problem. So here, in step 2, you go slowly. You are not aiming to zoom through the early problems. You are actively looking for things you didn't understand, okay? It's not like, oh, I'm good. No, no, no. You gotta make sure you totally understood everything, okay? Once you feel you've eliminated all the gaps, you go back to the beginning, check the book, check your algebra, remind yourself of algebra steps and so on. You kind of cycle through these step 1 and 2, coming back to the problems until you've completely done them. Then you can move on to the harder ones. So do more plus harder problems to achieve fluency. All right. And this, step 1 and 2, don't think of it linearly. You will be cycling through. Go back. Okay, go back to the basics. Also, the book has even and odd problems, and there are more problems than just what I give you, right? You might do neighboring problems to even those that I didn't assign for you, just so you can get more practice with these early things to fill in all the holes, fill in all the gaps, and then move on. Okay? Don't move on having not filled the gaps. It is perilous. You can definitely collaborate on homework. Talk to your classmates, absolutely, no problem with that. However, the work should be your own. Finally, you will upload the homework. So homework is, so we do it following. I assign the homework on Friday. It's completely finalized. Friday of this week. The homework for next week will be finalized. It's due Thursday, okay? You upload it to Gradescope. I will then give you 6 full days to do your homework from Friday to Thursday. And then the next homework will be finalized Friday, due Thursday, and will always be on this rhythm. I will never give you 2 days, pop, to do the homework, okay? Always fixed rhythm. All right, when you turn the homework, you will grade yourself. So also, the homework problems I assigned have solutions in the back of the book, okay? So you can check if you got the answer right? And you will grade yourself by assigning grade 2 if close to 100% right, grade 1 and completed. If close to 50%, and grade 0 if it's closer to 0%, okay? So when you turn in your homework, you also grade yourself. No 1.5, okay? And you'll turn it in on Gradescope. Everything else in this class will be based on this homework, okay? The quizzes will be, so quizzes will drop lowest 2. and they are similar to homework. And similarly, the midterm and the final, they'll all be problems that are similar to homework problems. Not exactly the same, but same ballpark kind of problems, okay? So if you've really understood your homework, you've done it well, no problem at all. All right. Okay, so with dropping the lowest 2 quiz scores, there are no makeup quizzes. If you have to miss the midterm, I told you exactly which date it is, okay? You have to do the following. You are going to write to me and say, I have a pressing reason, like, you know, just something, okay, before the exam, okay? Not during the exam, not after the exam, before the exam, like well before the exam, days before the exam, okay? I have to miss the exam. If you do that, your final will weigh more, will weigh for your midterm exam. If you do not do that, you do not let me know, you do not get my approval that yes, you can miss the midterm, you will get a 0 if you miss it, okay? So there's a big difference. If you let me know, you get my approval, there are no makeup exams, it'll just your final exam will weigh more, okay? Questions about this? Questions? Yes? Any copy of the book that you work well with, okay? They're all fine. Yes?
You mentioned that the homework is due on Thursday, but I think because this is Friday.
It should be, we'll modify. Here's why I'm telling you the homework will be due on Thursday. Because your quizzes will all be on Thursdays. And the way it's going to work is when you turn in the homework, okay, the quiz will include the material up to that homework that you're just turning in, okay? So I don't want to give you until Friday because you want to be ready for that quiz. And the exams, all of my exams, you don't think of them as, oh my God, you know, it's some scary thing. Somebody's going to do something to me. No. I would eliminate all the exams if you would learn anything. If there was a way of learning something in this class without the pressure of, okay, at this exam date, I'm going to check what I've actually learned, so I'm not kidding myself, right? With ChatGPT and what have you, you can solve your homework problems, like, you know, your homework's done, like, you can just feed it into ChatGPT. It will do it for you, right? I know it, right? That's our reality. However, you do that, right? It's also our reality that what your aim is in this university is to find something you are going to be amazing at, okay? AI will be able to do anything that an average human can do. What it will not be able to do is do the things that brilliant people do. And brilliance has many sorts of shapes. You need to find your own, okay? So don't give up a fight, not right away. Yeah, and so I fully believe that every one of you, no matter what kind of background you're coming in from high school, can succeed in this class if you work diligently. All right, we have one further resource that I want to tell you about, which is the Student Learning Center. And would you come and tell us about it, please? So this is an important resource you should definitely make use of. So if you go to our syllabus, great, thank you, Emily. Do make use of any and all resources available to help your learning, okay? SLC is a great one. If you go on our syllabus, you will see homework until the end of the semester. Now, you'll also notice that it's all one color. So all that homework is actually preliminary, okay? I will assign homework depending on actual homework, depending on the speed we go at. So when the homework becomes the actual homework, it will flip color, okay? That way you'll know, okay, this is what's actually assigned as opposed to just some placeholders. And here's homework. So homework will be, they call it diagnostic test. We'll upload the sheet with the actual problems. The purpose of this is for you to check how comfortable you are with algebra. Because again, for most people, those who find calculus hard, the main problem is actually algebra. Holes, right? Math is like building a house, right? That house has to have solid foundations, which can be fixed, but you gotta look for holes. You don't fix that hole, it's gonna come back to haunt you, and you don't want that. All right, so test A. It will have problems 1, D, and F, 2, C, 3, A to D, 4, A and D. So A to D means A, B, C, D. 5, A to D, 7, A, 8, A and B, 10, A. I said there's a lot of homework. Test B, 1, problem 2, problem 4, and test C, the same. 1, 2, and 4. Question, when is this going to be due? It's going to be due when? Next Thursday in section. Okay? All right. And not in section, it's due on Gradescope. All right. So now let me tell you a little bit more about what you're going to learn in this class. So we'll learn how to solve three kinds of problems. They will all sound extremely specific. The area problem, something called the tangent problem, and something called the limit problem. Now, while they sound very specific in various guises, they appear everywhere. Where they won't be manifestly related to the area, but they will, nevertheless, it will be solved by the same methods. And this, I'm supposed to say various, but it would have been better said different. All right, so for example, the area problem. All right, so let me give you a graph. Okay, so here are some 2 axes. and I draw a graph. And then I pick some points on the horizontal axis. Let me call them A and B. And I shade the area under the graph between A and B. Okay? And let me call this. So question, compute area A. So this is A. Okay? So I want to know what is the value of this shaded area. Okay? Now, and I could do this for an arbitrary red curve, like it could be very complicated. Okay, and here's the idea how we're going to do it. We'll approximate A, the area we want, by simple to compute areas of rectangles. For example, okay, I'm going to make it approximate, meaning you're not going to get the exact answer. We'll make a mistake. But hey, I won't be wildly off. So what I'll do is, instead of trying to get this exact area, I'm going to replace the area I want by a simple to compute area of, let's see if I can get this working for me, by a simple to compute area of a large rectangle, but which is an actual rectangle, okay? Some kind of rectangle. Okay, now let me make this a little bit sharper. So I trade the area I actually want by the area of this rectangle. So let me call this A1. Of one rectangle. A well-chosen rectangle. It's not some random rectangle. But as you can see probably from this picture, this rectangle pretty well approximates the area that I want. Now, how am I going to compute that area? Here's what I'm going to do. I'm going to take a yardstick, okay? And I'm going to put the yardstick along the horizontal axis. So this is equal to area of the base, to the product of the length of the base times the height of my rectangle. And so that guy is clearly easy to compute, right? Oops, sorry, don't move on me. Right? Is it clear that this is easy to compute? You don't need anything fancy, okay? So A is the area I want is approximately equal to A1. But not exactly. Equal. Now I can do better using the same idea. The idea being that area under some complicated graph is hard to compute, but areas of rectangles are easy. So let me try again. Okay. Now I'll do the following. I'll trade. Instead of why should I just use one rectangle? Let me use several rectangles. If I use several rectangles, I'm going to make a smaller error. Let me try this again. All right, so now I'll divide this into four areas of four rectangles. Okay? And now my rectangles will come closer to the actual graph, and I'll make a smaller error. Let me try to see if I can show you that the error is manifestly smaller. I make a smaller error, okay? So I'll take this rectangle and this rectangle and this rectangle and this rectangle. And now I will call A sub 4, which is equal to area of 4 well-chosen rectangles. Okay? And now A4 is a better approximation to A1, to A than A1. Because the places where I overcount and undercount, I over and undercount less. Okay, so let me try to clean this up a little. All right. Okay, and so finally, we will say that the area A is actually equal to the limit of A sub n. This guy is area of n rectangles as, so I'll divide it into not 4 rectangles, but maybe 1,000,000 rectangles, okay? As n tends to infinity. As n becomes large. Let's say it differently. And notice here the word limit. Okay, we'll talk about this at great length, exactly how you set this up. But by taking more and more rectangles, I can clearly make an error as small as I want. I can get as close as I want to the actual answer to solve this area problem. And it turns out that the solution of this problem is formalized by integration, which you will learn about. And integration is one key concept that you'll learn about. It will basically, in the real world, it will not deal with just the area problem, but various kinds of accumulation problems. We'll talk about these applications at length. The second kind of problem you'll learn about is the tangent problem. So I again pick a graph. Okay? And now I pick a point on the horizontal axis. And let me call that point A. And my question will be, find the slope of a line tangent. Tangent means touches, but just barely, the graph at point, let me call it P. So who's P? Well, picking A on the base will determine some point P on the actual graph. Okay? Actually, let's even forget about A itself. So I just want to know the slope of a point on of a tangent to the point on a graph. So this line that I'm after that just touches the graph, what does this look like? So here's how it looks like. Okay, so it's a straight line that touches the graph at P. Okay, and it looks like this. So this is tangent at P. And I want to know its tilt. I obviously know which point it passes through. Well, it passes through P. But to actually determine the line, I need one point, and I need to know the slope. So to determine that line, I just need to know what is its like, you know, how much tilted it is. And the answer is the following. So how will I find that tangent line, or how will I find its slope? I'm going to cheat. I'm going to pick a different neighboring point. So here's a neighboring point on the graph. Let me call it Q. Okay? Now, with 2 points, I can find the slope of line through P and Q. Let me call that slope M, P sub Q, okay? The point is that if you have 2 points, and we'll review that as well, that if you have 2 points on the plane, you can always write an explicit formula for the line that passes through those 2 points, and in particular, you actually know its slope. So with P and Q, it's easy to write down an equation for a line that passes through P and Q, okay? And P sub Q. And we'll also review the meaning of the precise word slope. And this guy has slope M. And that slope M is what I want, okay? So it's easy to write down the formula for what is M sub PQ. Easy formula. And then the key thing is M is equal to the limit of M sub PQ as Q tends to P. Okay? And notice that there's a word limit that arises here. So the third thing we'll learn is what it means to find a limit. A limit of something. All right, so these are the 3 kinds of problems: the area problem, the tangent problem, and the meaning of the word limit that appears in both that we'll learn in this class. And we'll also learn about applications. Ah, yeah, good. And finally, the tangent problem has to do with derivatives. And that's what we'll learn as well. That's it. And let me fix this word. Oh, we have 2 minutes. Don't get up yet. The class is over when I say it's over. Okay? Derivatives. So we will spend the whole course developing these 3 things, and in the process, developing fluency in algebra and calculus. All right. I hope we all have a great semester. I look forward to it. It's going to be work, but if you put the work in, you're going to get a mountain out. Okay. See you Friday.